Thank you for joining me today to look at 3D Experience for SOLIDWORks users. Almost all Dassault Systèmes software is available on or connected to 3D Experience, and today I'd like to focus on a few functionalities that particularly benefit SOLIDWORks users like myself. The first of which is connected communication. We all expect our SOLIDWORks data to be completely connected. When I make a change to a part file, that change is immediately reflected everywhere else. So why do we allow a disconnect when it comes to communicating about our designs? Well, probably because the connected tools simply didn't exist until now. I'm sure you are already familiar with apps out there like Microsoft Teams or Slack, but having purpose-built tool sets that are fundamentally connected to your design data is incredibly convenient. Second, every SOLIDWORks user has some need for proper data management. Whether you're collaborating with a remote workforce, searching for the latest revision of a file, fighting for write access, or maintaining a server drive, maybe you simply lack a bulletproof data backup scheme, product data management is the backbone of 3D Experience. If you are currently without a purpose-built data management tool, 3D Experience is your easiest entry point to solving these problems. And finally, 3D Experience is the gateway to accessing additional Dassault Systèmes software, such as incredibly powerful simulation tools and 100% cloud-based design tools such as xShape, which I'll be covering today. So with those points said, let me get right into it. First up on the agenda is to discuss cloud collaboration, where I'll be working on the cloud platform in a multi-user environment, communicating and sharing data. Next, I'll introduce the 3D Sculptor role and show a sub-D modeling program which is fully cloud-based, all inside of a web browser. On this project, I'll actually be working to redesign a carving knife into a cordless version, so I'll take that sub-D modeling back into SOLIDWORKS and add a higher level of detail for manufacturing. Of course, we need to see what happens when a design change is made on one side of the equation, and finally, that design change will need to come back into SOLIDWORKS, updating the manufacturing info, and then producing a drawing for production. And of course, this isn't the only workflow we could use. Since everything is connected bidirectionally, we could easily start our work in SOLIDWORKS. So let's kick this process off on the 3D Experience platform itself, which is accessed through a web browser. Here in my 3D Experience dashboard, I have tools like a cloud-based file viewer, bookmark files, and I can even get into data management, but the first tool I'd like to focus on is this 3D Swim community. This is essentially a message board and is particularly nice for keeping interested parties in the loop, but not spamming the entire office with reply all email chains. An idea post was created with a few images to draw inspiration from, allowing everyone involved to throw in their 2 cents. Once a path forward is chosen, we can take this to the next step by creating posts that assign particular tasks to specific people with deadlines on it and attachments. I'll just reply to the post that I'm on the job and also mention a coworker who I want to create some concept art. As a SOLIDWORKS user, getting started is as easy as dragging and dropping the legacy design straight from the platform into SOLIDWORKS. That's how integrated these two areas are. Now, once inside of SOLIDWORKS on my local computer, the task pane provides a great deal of useful information, including what files I have open, who has control of the files, and what revision they're in. In order to take control of this assembly and gain write access to it, I simply need to right-click and reserve it. I'm going to bump the revision of this legacy design as well by simply choosing Save with Options on the right-click menu and checking New Revision. I'll add a comment for why I'm adding this revision. We're going to the cordless model here, and I can also access the rest of my 3D Experience apps in the same SOLIDWORKS task pane, one of them being the Collaborative Tasks app. This app tracks that post that was just created in the web interface, and I can drag it and change its status from to do to in work. A huge benefit of cloud data management is searching for data. And now that I'm working on this new cordless version of this carving knife, I'm going to search my entire platform for anything with the term battery attached to it. Results are returned very fast, and I can add additional filters and even quickly preview the file to ensure it's the correct one prior to pulling it down. Of course, once I've located here what I'm looking for and I ensure it's the correct battery to get it into SOLIDWORKS, just like before, all I really need to do is drag and drop. In this case, I'm going to show off my preparation a little bit and flex here in SOLIDWORKS and just add one origin to origin mate, which will line things up perfectly. And instead of only saving this file locally, saving through this same task pane immediately pushes my changes back to the cloud. Common save options like keeping the file reserved and checked out to me or organizing it with bookmarks are available inside of that same dialog. But am I really done working on it? I mean, not only is the previous shape not very ergonomic, not very good looking, my battery completely interferes and sticks straight through the handle, so not very functional. So maybe that's the job for the industrial designer, whoever comes up with this curvy handle shape. So I'm going to add a new task the same way, creating a collaborative task, and just open it up and assign that work to them. I can add a description, keeping it in the to-do maturity state because it's not my job, but I can assign it to a specific person or a number of people, even groups of people like myself. Something I like to do on here too is attach the relevant file. So there's no need to search or questions about which file it is. They can grab it right from the attachments. Saving this task, I'll head back to the platform because my changes are immediately available there. I could really see this by dragging the assembly into 3D Play, the integrated file viewer. And I'm going to use this tool to do some additional markup for others to see as well. These are powerful annotation tools that are similar to e-drawings. You can measure, section, explode, and markup. What I like about using these here too is I can capture this image straight into a community post. I'll just make sure this is posting into the right community, maybe add a description, and as soon as I publish, this post is then available back in the 3D Swim app where I could add a comment. Maybe it's a good idea to @mention somebody I want to get an automatic notification about this change, and also give visibility to just anyone who's interested in signing in and checking out my community. So while I've only scratched the surface on collaboration tools here, I hope you can see how they are completely integrated with the design process. While you may have access to other communication apps out there, having purpose-built tool sets that are fundamentally connected to your design data, like a 3D model viewer with annotations that post right into communities, is ultra convenient. Now let's get to fixing this legacy handle design with sub-dimensional modeling. And this is a CAD functionality that, believe it or not, SOLIDWORKS itself doesn't have. I'm going to utilize xShape for this from the 3D Sculptor role, and this is particularly powerful for creating ergonomic and stylish industrial designs. This is actually how the legacy handle design was created in the first place and eliminates the need for lengthy surface modeling. So here I am in xShape, the cloud design app, and of course the communication tools are here as well. Exposing the collaborative tasks app here in the platform is just like you saw in the task pane of SOLIDWORKS. And now I can move this task from to do to in work. And you can see just how convenient it is to attach the relevant files to tasks and completely eliminate the need to search them up. I just drag in the relevant file from the task. xShape is a single modeling environment. So while there's a tree structure and an interface that's very similar and familiar to SOLIDWORKS, it's pretty standard to create parts right inside the assembly, which is what I'm going to do here for the new handle. I'll start with essentially a napkin sketch that was posted in a community, just like I would start with a sketch picture before maybe doing a lot of surfacing operations inside of SOLIDWORKS. Using the on-screen points method, scaling and positioning the picture is really nothing new, and if you've done this in SOLIDWORKS, well, you'll probably know how to do it and get it in the right spot in xShape to get things started. What is new is that every sub-D modeling task begins by inserting something called a primitive shape. A primitive is a digital hunk of clay that is subdivided into sections that are controlled with points. I like to keep things simple, and I advise you do by starting with a low number of points, and then you can push, pull, rotate, and scale these points to where you need them to be. In areas where I need additional detail and want to get kind of more microscopic, I can just insert loops and kind of insert more points just in the places where I need them, not unlike adding more points to a spline. I'll simply select an edge, and using the pop-up menu, I can insert 2 loops across it. Notice that similar to SOLIDWORKS, as I make selection tools that I am most likely to use, there's a pop-up menu right next to my mouse suggesting, hey, here's maybe your next step. There's also very familiar keyboard shortcuts you'd expect, like hitting the delete key here to remove an edge. So this is the primitive I'll begin with. I'm just going to adjust the transparency so I can see my sketch as I work on the design, and I also like to enable symmetry in xShape because there's a lot of symmetry in my design, and as I work, these changes will happen on both sides. Note that by default in xShape, every face has C2 level curvature with its adjacent faces, so everything's perfectly smooth, but I can add creases anywhere in the model I'm going to need a hard edge. For instance, this front face needs to end up as a completely 100% flat surface that I could sketch on like in a 2D sketch in SOLIDWORKS. Also, very conveniently here, if you double click an edge, this selects the entire tangent propagation of that edge, something that's just very fast for selections. Now, using this method along with these pop-up or contextual menus, I can crease long edges or loops down the full length of the part, and my symmetry command automatically took care of the other side of the model for me. If I need additional detail in certain areas, I can just subdivide that face to gain more control points. You can have as many subdivisions and control points as you want, but I'd keep it simple, and really I need to work on the top side here, where I'm going to use some familiar selection tools and window selection methods. Now, I do need to be careful here that I don't unintentionally crease the bottom side as the top, if I've got symmetry turned on or I'm selecting through geometry. So I'm a big fan of the option to only select the visible faces for whatever orientation you're in. So let me grab those faces again with the filter on, and again the shortcut menu is predicting where I'm most likely to go next. I'll subdivide these faces to add an internal loop, put in a hard crease on my new loop, and just disable my selection filters. I think it's also a good idea around now to utilize a bounding box, really just to make sure I stay true to the overall size I was aiming for. So while I can always push, pull, and rotate and scale things into place, a more precise and more accurate method can be used by just scaling everything with a bounding box, and that doesn't have to be uniform. So even though it feels like I'm working with clay, I can still be accurate about the proportions and the overall size. Like this was supposed to be 60 by 200 by 75. Once I get things down to size and I just drag to position them up where I want them, I'll bring back my napkin sketch, maybe turn on through transparency and re-enable symmetry so I can really dig back into the design task. Now most of this is done with symmetry enabled and by simply pushing and pulling points. If you've ever done this type of processes in traditional CAD surface modeling, you'll know that it can be quite a lengthy job. Note that I'm not messing with multiple 2D sketches with splines, projected curves, or dealing with lofts. And I'm getting real-time 3D feedback. I'm not just having to enter and exit a 2D sketch to see the effect on the 3D geometry. This really lends itself to creating artistic, ergonomic, and complex geometry without the mental disconnect that comes with a guess and check type method. And of course, some of this does need to be prismatic and accurately measured here. You've seen what can be done overall with the bounding box, but locally, I can use tools like align entities by line to get an exact straight line and a flat face. Just going to drag this line and get it where I need it, but also make sure I snap it vertically to ensure that it's perfectly flat, again, so I can make 2D sketches on it over in SOLIDWORKS. And the same technology works for curves as well. Instead of manually manipulating the control points at the bottom of this handle, I can use a similar technology for curve shapes through Quick Align with Sketch. Now I could just freehand a curve out there with my mouse, and the control points attempt to align with it, which is pretty cool. So I'm mixing together here functional mechanical design with more artistic industrial design methods. And at this point, I think it's looking pretty good, honestly. I might tweak a few things here, but minus the trigger mechanism, at least from this side view, yeah, this design's coming together. Looking at the top view, I think I could improve the shape really just by scaling things down. So I'm going to grab loops that wrap completely around the whole part. Dragging the arrows will move them, but dragging these dots will scale them. It's good to rotate and move the view around a bit. Here, if I move, more into an isometric orientation, you can see where I'm going with this overall 3D shape of a hand grip. Similarly, around these same arcs, if you choose faces or points, there are two handles and an arc in between them for that control point. That arc allows me to rotate and really tune the overall shape instead of thinking of just one flat orientation. So far, I've completely ignored the trigger mechanism on the bottom of this part, and one way to address that would be to extrude. So add more material, just like adding additional clay. Similarly, I could cut holes where I need them and work with additional primitives. Let's just scale this down a bit and just use the same push, pull, scale, and rotate tools to more closely match up with the original napkin sketch. And now, as I work here and finish up the design, I want to point out that what I'm going to get out of this is a real B-rep or boundary representation solid body model. That means I could render, generate toolpaths with it, modify it in SOLIDWORKS, you name it. I'm going to make a few final tweaks and adjustments here before processing this into a single body. And that's what happens. These are really all surfaces that get knit together to form watertight geometry. And those of you familiar with NURBS surface modeling the traditional way know how involved this task can really be using traditional techniques and how much you're really looking for the C2 curvature continuity and the watertight model that you get here. Now, I mentioned that once before. This C2 curvature continuity is default for everywhere except where I've creased, something you can really see when interrogating with tools like zebra stripes. So I'm feeling pretty satisfied. I think this looks really good. I'm just going to save this and then make sure everyone is aware of how awesome this thing is by using those collaboration tools to communicate with the team. So that's sub-D modeling. The tools and workflows in xShape, it's a very quick way to model extremely complex shapes. It's this push-pull clay modeling nature of the technology itself that makes it so powerful and really easy to learn. In fact, I've just shown you the core workflows of the software, and I guarantee you could learn the rest of it in one afternoon from a couple short videos on my.solidworks.com. Not to mention that this was all done 100% on the cloud with no local installation required. So I've just gone from chatting about an idea and sharing pictures of it with coworkers in a community to an actual B-rep solid geometry that I could use for any downstream application. So with that said, let's take this thing over to SOLIDWORKS and add some detail that would be needed for manufacturing. Of course, I'm starting out again in the task pane of SOLIDWORKS, where I'm notified to check out the new design. Since it wasn't attached, I'll just search it up real quick. And what I'm going to do is create a new SOLIDWORKS part that I drag and insert the xShape component into. This way, as I add shells and other SOLIDWORKS features, they go into a SOLIDWORKS originating file. Now, once this is shelled down to a standard wall thickness, I'm going to use some master modeling techniques and edit this part in context of the assembly so I can measure off of adjacent components. And notice that I'm sketching right on the xShape file and making relationships with that new SOLIDWORKS part origin. I need to create a cutout for the blades, and using the origin and just adding a few dimensions allows me to build a fully defined parametric sketch that should play nice with any model updates. This is eventually going to be manufactured in mass out of plastic, and thinking of injection molding, I need to split this into two halves and to get to work on those internal mounting features. A simple split command breaks this into two separate bodies, allowing me to hide one of the bodies and start on the internal detail. Since I'm working inside the assembly, I can make use of convert entities in my sketches, and as I borrow edges and hole locations, I'm automatically making parametric relationships to them, allowing for smooth model updates in the future. And of course, as I add extrusions, I'm going to make sure that I maintain draft angles to avoid any problems with molding and manufacturing. And the whole reason for this new handle though is to support the battery needed for a cordless design, and it looks like there may still be some problems there. A quick interference detection tells me we're not quite done with this design, so the design cycle is going to continue. Yeah, that doesn't look too good. Parts flying right through each other. So on this side, you know what, I'm just going to save my edits, and using 3DEXPERIENCE in the task pane means my designs are immediately uploaded to the cloud and available to the entire team so they can see this interference problem and the job is not as great as we thought it was. So I'll just let them know here through the chat that there is more work to be done over on the industrial design side of things. I want to point out that the geometry came into SOLIDWORKS perfectly clean. There's no problems with importing or translating data, anything like that, and there's no limitation on what can be done with it inside of SOLIDWORKS. The task pane integration slides right into my workflows and takes care of all the data management for me. While SOLIDWORKS itself doesn't run in the cloud, its connection to it provides the data management, team collaboration, and the additional capabilities that I needed here. So then what happens when a change is made on either side of the equation? Well, let's jump back into xShape, make the fit changes that should have been done right the first time, and we'll see, what else we can improve since we're already here. I'm sure I'd be harassed in the chat for not completing the intended design here and make room for the new battery. And really what I should have done somewhere along the way was simply show all of the components of the assembly to avoid that. But it's really no problem to get back into the original shape and edit all those same control points just by pushing and pulling handles, or maybe adjusting the bounding box. I'm just going to eyeball a few adjustments, but I want to point out that you can also right-click any of these control points and make sure you're moving them along an XYZ coordinate system for accuracy's sake. Now, let's get a little fancier here too. One thing I'm going to do is angle this front face just so we have more room for working when this thing's actually operating. And if I do that, I might want to adjust the triggers so we've got a little more space there as well. And if I'm getting real fancy, I want to show you how to flex the entire thing using an arc bend tool. This tool allows me to place a handle, choose which points I want to control, and then simply bend them one direction or another. Take a look, I can pull this whole part up or down, curve everything I've done so far in bulk with this one arc bend tool. But if I do that, it looks like I actually created some new interferences, which I can see this time. And so I'm just going to pull a few points individually to deal with that. Maybe add a few finishing details here. I really should have just checked for interferences on this side. And honestly, it's probably a smart idea to check for draft as well, even if I'm not thinking so much about manufacturing. There's a full set of tools here, similar to the Evaluate tab inside of SOLIDWORKS. Part draft is needed for manufacturing, right? Angling away from parting lines where mold halves come together. But in this case, I also don't want the sides of the handle to stick out past the top face, purely for aesthetic reasons. I can see I have some overlay, and these analysis tools like this also update in real time, so there's no guess and check work. Looking at the actual parting line, there's no draft issues there, so I shouldn't get reprimanded by the manufacturing side, and I think that wraps up really a pretty slick handle design. Alright, saving this back, I might communicate my work as well. What you've seen is that on the xShape side, I'm able to modify that original design, really no problems at all, and then pull that back into SOLIDWORKS. That means that all downstream operations like the shell, the feature, the split, the extrude cut, the mounting bosses, they're all going to be affected by what I just did. So let's see how that's actually handled back in SOLIDWORKS, and let's finish up this project as well. It's probably going to need a manufacturing print. Now back in SOLIDWORKS, a quick refresh of my 3DEXPERIENCE task pane indicates that I don't have the latest revision of the handle file, but all I need to do is right-click or reload from server to pull the latest one down from the cloud. Immediately the file is downloaded and replaced without errors, while the task pane keeps me up to date on which files I'm working with. If I open the file up on its own, you can clearly see how the new larger shape, angled front edge, And all of my SOLIDWORKS features are up to date without rebuild errors. All that's really left to do on this thing is make a print or make a drawing for manufacturing. Now, I'm going to assume that you are all familiar with the drawing tools of SOLIDWORKS. They've been around since the beginning. And I'm going to be providing the 3D file here for manufacturing or mold making anyways. But what's common to do is also provide a print of some fine details, maybe just for legal purposes. And what I want to point out here is that there's no limitations to this geometry when it comes to downstream operations. It's truly a solid body and behaves as if I had made it in SOLIDWORKS with standard SOLIDWORKS features. That means you can create section views, detail views, even of course add dimensions wherever you want them to show those critical details, or where you need tighter tolerancing, like here at the blade cutouts, where I've made mounting bosses, the wall thickness, or just the overalls of the part for packaging. And as you might imagine, even this drawing is saved straight into the cloud with one right click in the task pane. Since I've completed the entire handle redesign, this time I can move my task to completed and of course attach the final deliverables to the task as well. So now, no one in the future would have to go searching. As I'm sure you expected, when you make a change in one place, that change is immediately reflected everywhere else. Updates flow from one application to another without any errors. So what you've seen here today is just one potential workflow of that kind of update process and for utilizing 3DEXPERIENCE with SOLIDWORKS. The integrated collaboration and data management tools were with me throughout the process and allowed me to leverage xShape, the cloud-based sub-D modeling tool, right into my usual SOLIDWORKS tasks. If you're currently running SOLIDWORKS without purpose-built collaboration or data management tools, or just interested in the additional capabilities of some Dassault system software, 3DEXPERIENCE is where it's at.